In today's video, we continue to look at motion, and we'll look at a question that will help us cement the concept that we've learned under motion. All right, so it reads: a car traveling at a constant speed. A car, so we'll say solution. Okay, a car traveling. So we have a car here traveling at a constant speed of 24 meters per second passes a trooper hidden behind a billboard. 1 second after the speeding car passes a billboard, the trooper sets off in chase with a constant acceleration of 3 meters per second squared. How long does it take the trooper to overtake the speeding car? All right, so we have a car and you have a trooper, right? Okay, you have a car and you have a trooper. Okay, so the data of the car is moving at what speed? At constant speed of what? 24 meters per second, right? So 24 meters per second, that is the car's speed. The trooper has constant acceleration of 3 meters per second squared, right? Okay, so the question is, how long does it take the trooper to overtake the speeding car? This is the speeding car, this is the trooper. The question is, how long does it take for the trooper to overtake the speeding car? Now, for those that drive, right, overtaking any vehicle on the road would have meant you had reached that vehicle in question, that vehicle's distance in question. Okay, so if car A is in front and you are driving car B, to overtake car A, you should have reached car A's distance enough to now overtake. You cannot overtake from distance behind, right? So you are overtaking a vehicle that you are of the same distance. Okay, so literally in this question we are trying to find how long does it take for the trooper to reach the same distance as the car, because it is only at that distance the trooper can now overtake the speeding car. Okay, so we are going to write equations that give us a distance for both the car and the trooper. Okay, so we looked at the equations of motion. All right, so we have speed is equal to u, okay, we have distance equal to ut plus half at squared, and we have v squared is equal to u squared plus 2as. We also had v is equal to u plus 80. Okay, so we isolate, we choose which one we are going to use now. Okay, so we'll use these equations of motion to help us find this question. All right, so we continue. We'll say, so which one are we going to use? We're trying to find distance, right? So this one is a potential and this one is a potential. This one is not a potential because it does not have distance. Okay, now this one, so for the first question, we don't have acceleration, right? We only have constant speed. All right, so we only have a speed at which the car is moving at. Okay, so our question was reading a car traveling at that. Okay, so we only have speed, and in that case this will take us some time because we don't have acceleration and we're again trying to find the speed, right? So this will not work also. It will take a bit of some time. All right, okay, so actually the acceleration we do have. Okay, let's just clarify that point. Okay, so the car, so if we're going to write an equation that is going to give us a distance of the car, we're going to get the car's data, right? So what do we have? We have speed, which is 24 meters per second. Okay, do we have acceleration? Yes, we do. Why do I say so? The car is traveling at constant speed. If an object is moving at constant speed, it means it is not changing at speed, right? And if there's no change in speed, or rather velocity, literally velocity, but when it comes to magnitude, we say they are the same, right? And so if there is no change in the magnitude, which can denote velocity, which means there's no change, which means there isn't acceleration, because acceleration is change in velocity. So without change in velocity, you have zero acceleration. Okay, so we are going to use an equation and we are trying to find a distance. Okay, now our initial velocity that we've gotten right about now is what? 24 meters per second. Okay, 24 meters per second, right? And then we do know that our final, now we do not have our final. Why do I say so? Because from the question, it starts at, the car in the question has started at 24 meters per second. Okay, we are not sure of the final velocity it will attain a bit later, right? So all we know is its initial, but since it is constant speed, we are getting zero acceleration. Okay, so in the meantime, we don't really care about the next velocity because it has not changed speed just yet. Okay, so in that case, we don't entirely have use for this. Again, makes this equation not the most favorable. Okay, so we settle for the first equation. Okay, now what are we finding? We are finding the distance at which the trooper will find the car. Okay, so that they become at that equal distance. All right, because if a car is moving at 24 meters per second, right, it is traveling, and we're saying the trooper is behind a billboard. Okay, so this is where you have a billboard, right? You have a trooper there, it is resting, right? The moment this car passes, okay, 1 second later it would have traveled a certain distance, right? Okay, now our speed is 24 meters per second. This just means in 1 second this car is traveling a distance of 24 meters. Okay, so by the time the trooper starts to journey to chase the car, it would have traveled a distance in 1 second, right? Because that is the reaction time the trooper had taken. Okay, so in that 1 second the car would have moved 24 meters already. Okay, which means 24 meters will be the initial distance at which the car starts from with reference to the trooper starting the chase. Okay, so initial distance will be 24 meters as we try to find the final distance at which, okay, let me write this. All right, so we have initial, okay, in fact let me do this. Initial distance will be 24 meters. Final distance will be the distance we are trying to look for. Okay, so now since this is where it's going to start, 24 meters, it will continue moving, right? As it continues moving, the trooper now starts to follow. Now the question is, we're trying to find at this distance, what is this distance? Because this is a distance where the trooper will try to equivalent to, right? This is the distance we are concerned, the final distance. From 24 it would have traveled a certain distance, reach this distance. This is the distance that we are trying to look for, because this is a distance that the trooper will equal to. Okay, all right, so that is our final distance. That is why we'll have initial and final. 24 initial and final and sure, because that is what we are going to look for now. All right, traveling at still constant speed. Okay, so now our data is this for the car. This is our data. These are the distances. Okay, then we also have speed 24 meters per second. We also have acceleration 0 meters per second squared. Okay, do we have time for this journey? No. In fact, time is what we're looking for, because the question is how long does it take to travel to reach that point, right? Which is the distance that will equivalent to the one for the trooper. Okay, so literally, how long does it take this billboard, this trooper, to reach that distance? Okay, which is going to still equal the distance for the car. All right, so we are going to write the equation for distance, this one which looks favorable. Okay, so it is squared. All right, so our speed, our distance, this is a change in distance. Okay, is equal to initial. All right, initial multiplied by t plus, we know acceleration is 0, so this part is 0, right? Okay, so change in distance, we have final minus initial is equal to ut now. Okay, so our final is unknown, is equal to ut plus our initial. Ut, what is our initial, is 24 meters per second multiplied by what is our time, that is what we're looking for, plus our initial distance is 24 meters, okay, which is xf. So final distance is equal to 24t plus 24. This will be our equation 1. All right, our equation 2 will be 1 for the troop. Okay, we want to find the distance of the troop. All right, again we choose among the 3 equations, but we already know, since we're finding distance, we only have 2 to choose from. So we have this. Okay, again we do not, again we have initial, right, because the trooper was starting from rest, right, because it was just behind, which means we already have initial to be 0 meters per second. Okay, we do not have final, so this one won't be very conducive. We do have constant acceleration, right? Its constant acceleration is what? 3 meters per second squared, right? Okay, so we are looking for time, right? We're looking for time, but we're writing equations of distance because we are trying to equate the 2 distances. Why? Because that is the only time, the time that would take to reach the distance equal to the car will be the time the trooper will then have to overtake the vehicle, right? That is why we are writing equations of distance, so that we can equate, and then that will help us to find our time. Okay, so we continue. So our, let me write x is equal to, now distance final minus initial. Our initial is 0 because the trooper was not moving, so we only have our final there. Okay, our initial is 0, so 0 multiplied by 2, this part will give you just 0, so you only remain with half a t squared. So you have final is equal to half, what is our a? Our a is 3 meters per second squared multiplied by t squared. Okay, so now we have xf is equal to half multiplied by 3 t squared, which you can write as, so when you're multiplying this, multiplies only the numerator, right? So you have 3t squared on top over 2 is equal to xf, right? Okay, so we have, this will be equation 2. We can now equate the distance, the earlier distance, which was 24t plus 24, and this was equation 1. So we can now equate these distances to equal the same. So while we have final, we can replace it by that. So we have 3t squared over 2 is equal to 24t plus 24. Okay, so you can do this, you can multiply, right? You have 3t squared is equal to 24t plus 24 multiplied by 2. So you have 3t squared is equal to 2 multiplied by 24, right? That gives you, okay, this gives you 48t plus 48. Okay, so you have 3t squared, you can bring this aside, you have minus 48t, change side, change sign. This is positive, it changes side, it becomes a negative also. This will be 0. Now we can now solve this as a simultaneous equation. All right, so for starters, 3 can go into 48, right? So you can divide, so you can have t squared is equal to 48 divided by 3 gives you what? Gives you 16. Oh, sorry, this is a minus. 16t minus 16 is equal to 0. All right, so now that you have that, okay, you can either use sum and product, or you can go with the typical quadratic equation, okay, which always gives you a value, right, whether you have factors or not. Okay, all right, so this is A, this is B, this is C. All right, okay, so sum and product might not be conducive because the values are not going to happen, right? Okay, so we can settle for the quadratic equation, right? So t is going to be negative, b positive. I hope you remember this quadratic equation, right? That will be that. Okay, so our t is going to be, what is our b? So you have negative is not part of the b, right? The b is on its own, which is negative 16, right? The constant value is what we consider, right? Plus negative, the square root of b is negative 16 squared, okay, minus 4. What is our a? Our a is a constant, which is 1 multiplied by negative 16, which is our c, right? Over 2 multiplied by, what is our a? 1 again, okay? So t is equal to negative will give you positive, so we have that, okay? Now 16 squared is what? 16 squared is 256. So 256 minus 4, that will give you negative 16 inside there, over 2 times 1 will be 2, right? Negative times negative will give you a positive value, right? So now you have t is equal to 16 positive negative. You have 256 negative positive, so you have 16. All right, so negative times negative positive, 4 times 16 gives you 64, okay, over 2. So you have t is equal to 16 positive or negative, so you have 64 plus 256. All right, so 256 plus 64 gives you 320 over 2. So t is going to be 16 positive or negative. Okay, so the square root of 320, so the square root of 320 gives you 17.888, so would you say 17.9 over 2, all right? So now you have time is equal to 16 positive 17.9 over 2, or another t, which will be 16 minus 17.9 over 2. Now this one will give you minus, because the top will give you a negative value, right? You cannot have time which is a negative value in this concept, all right? So we'll set off one that gives you a positive time, right? That gives you positive time. So you have 16 plus 17.9 over 2. Put this in brackets, this will give you seconds, right? So t is equal to, so you have 16 plus, so you have 16 plus 17.9, 33.9 divided by 2. That will give you 16.95 seconds, right? Which can also be t is equal to 17 seconds, or rather, since 3 significant figures, yeah, you can use 2 decimal places sometimes, but or you can have 17.0 seconds, yeah, whatever works. But in this case, well, either way can still work. I do advise students to stick to 3 significant figures, so this could be okay. But like I said, both are right. Okay, let's continue. So now we find the time at which the distances can equate, which means that is a time that we are concerned, and that is how long it will take the trooper to have reached the car and then overtake it. All right, 17 seconds. All right, so now what is our next question? So our next question is, all right, so we continue. All right, so so that's about it. However, when the final answer, I recommend 3 significant figures, right? But then sometimes with the quadratic equation, it would be advisable to get the whole answer. Like the square root of 320 gave us 17 point, with all those points. So you can go directly and add plus 16, then divide by 2, which will give you 16.944. So which would have given us a different value there to be 16.944, which we can then just say 16.9 seconds. Which we can just say 16.9 seconds, okay? But however, both answers are within range, so you can either go with any. All right, so we continue to the next question. The question is, how fast is the trooper going at that time? How fast? What are we looking for? Speed of the trooper, right? Let's collect the data for the trooper, right? So for the trooper, what do we have? The trooper, we've said it is moving at constant acceleration, right? We know the time, which is either 16.9 seconds, whichever you choose, really. Or what else are we looking for? So we already know it was coming from 0 because it wasn't moving, so we have its initial. We are now looking for its final, right? Now if we're looking for its final, what equation are we going to use, right? We know we can use this equation because it has all the variables. We have that, we have that, we have that. So we can say v is equal to, what is initial there? Initial is 0 meters per second plus what is acceleration, 3 multiplied by what time is it? So what is our time? Our time is 16.9 seconds. Or like I said, you can go with 17 seconds, all right? So 3 multiplied by 16.9 gives you 50.7. So V is equal to 50.7 meters per second, right? Even if you did multiply 3 multiplied by 17, it will give you 51, which it will give you 51 meters per second, which is literally in the same range, right? So this will be your velocity. With whatever value that you go with, it will still be correct. Okay, so this is how you go about this type of question, right? I hope it's understood, and I hope you've learned something, and if so, be kind to share with your friends and the people that you think can benefit from this. Thank you so much. We'll meet in the next video.